guys, welcome back to my YouTube channel. In this video, I'm going to discuss about trigonometric identities. For this discussion, our objectives is to familiarize oneself with trigonometric identities and prove trigonometric expressions. A trigonometric identities is an equation that involves trigonometric functions and is true for all values in the domain. Magic hexagon for trigonometric identities. This hexagon is a special diagram to help you remember some trigonometric identities. As you notice, this hexagon has the 6 trigonometric functions that label to its angles. We have here a tangent, sine, cosine, cotangent, cosecant, and secant. Also, at the center of the hexagon, we have a number 1. For you to remember, the cofunctions such as the cosine, cotangent, and the cosecant are all on the right side of the hexagon. The quotient identities. To start with, let's have an example. Tan theta is equal to sine theta over cosine theta. So how did we come up with this equation? By using the magic hexagon, we can determine if this equation is true. We'll draw an arrow that starts from the tangent, pass through the sine, and ends our arrow at the cosine. So that's how it looks like. Remember that the function where you start to draw your arrow is the quotient. Like in the example, the quotient is the tan. So these are the result of the quotient identities in clockwise and counterclockwise rotation. Now let's proceed to the product identities. The hexagon also shows that a function between any two functions is equal to them when multiplied together. If they are opposite to each other, then the 1 is between them. For an example, tan theta multiplied by cosine theta is equal to sine theta. By looking at the hexagon, sine here is in between the tangent and the cosine. So sine is the product. Another example, tan theta multiplied by cotangent theta is equal to 1. And by looking at the hexagon, 1 here is in between the tangent and the cotangent function. So 1 is the product. Now let's proceed to the reciprocal identities. You can get the reciprocal identities by going through the 1. For an example, sine theta is equal to 1 over cosecant theta. To sketch this example, we'll draw an arrow that starts from the sine, pass through the 1, and ends our arrow in the cosecant. So that's how it looks like. Here are the full set for the reciprocal identities. The last one is the Pythagorean identities. The magic hexagon helps us identify the Pythagorean identity by going clockwise or counterclockwise direction in any of the 3 triangles, the one in the shaded part. Since we're talking about Pythagorean, the trigonometric functions are in squared. Let's first have an example in clockwise direction. By going clockwise, our operation will be addition. For an example, sine squared theta plus cosine squared theta is equal to 1. If we sketch it in the hexagon, it will look like this. 1 here is the sum since it is where the arrow ends. So that's how it looks like in clockwise direction. In counterclockwise, the operation will be subtraction. For an example, sine squared theta is equal to 1 minus cosine squared theta. If we sketch it in the hexagon, it will look like this. Sine squared theta here is the difference since it is where the arrow ends in counterclockwise. So that's how it looks like. So here are the full set in the Pythagorean identities. If you have any questions, clarification, and suggestions, kindly comment it down below.